Okay, so for this lesson, we're going to take a look at the relationship between linear scale factors and area scale factors. So we start by solving the areas given an original dimension. If my dimensions are 3 by 5, I'm going to multiply them and get 15. If I have a scale factor of 2 to 1 or of 2, then I'm going to double each of those to get 6 and 10. 6 times 10 is going to be 60. And if I say the new area of 60 divided by the old area of 15, it's going to give me 4 over 1, or 4. I can do the same thing for the next one. I'm going to say that if I have 9 times 6, I have an area of 54. If I multiply it by 1 over 3, then I'm going to have 3 by 2, which is going to give me an area of 6. An area of 6 divided by an area of 54 is going to give me an area of 1 over 9. For the next one, if I have 4 times 8, it's going to be 32. If I multiply it by 3 over 2, then 4 times 3 over 2 is going to give me 6, and 8 times 3 over 2 is going to give me 12. 6 times 12 is going to give me 72. And if I have 72 over 32, I can divide both of them by 8 and get 9 over 4. For the last one, if I have 3 times 12, it's going to give me 36. And if I'm multiplying it by 2/3, 3 times 2/3 is going to be 2, and 12 times 2/3 is going to give me 8. 2 times 8 is going to give me 16. So I have an area of 16 divided by an area of 36. Then I can divide the top and the bottom by 4 and get 4 over 9. Now, we can see when we take a look at these that the scales are not equivalent. In this one I had 2, but then it became 4, which means that I had to multiply it by 2 again. In this one I had 1/3, and in the area I had 1/9. I multiplied by 1/3 again. In the next one I had 3 over 2, and it was actually 9 over 4 in the area one, so I multiplied it by 3 over 2 again, and logically speaking, the last one, I multiplied by 2 over 3 again in order to get the 4 over 9s, which means that the area scale factor is the same as the linear scale factor multiplied by itself again, or the linear scale factor squared. If Maggie is scanned an 8-inch by 10-inch photograph to her computer, and she'd like to increase the size of the area by 44%. Determine the area scale factor for this one. Well, the area scale factor if she wants to increase it, is going to be the initial 100% plus another 44%, which would be the same as 144%, or 1.44. If I'm going to use this to determine the linear scale factor, well, if 1.44 is equal to the linear factor squared, then I'm going to have to square root both sides in order to solve this. And I'm going to say that 1.2 is equal to the linear factor. Why are these scale factors different? Well, because the area scale factor is the linear factor squared. What are the dimensions of the enlarged photograph? Well, if the linear scale factor is stating that it's going to be 1.2, then I would say that it's going to be 1.2 times the 8 inches by 1.2 times the 10 inches, which means that the new scale is going to be 9.6 inches by 12 inches. The enlarged photograph will be printed at a digital print shop on color printer. Assuming the white areas of the photographs will also use ink, calculate the area the printer must cover by the following two methods. Well, if I'm using the dimensions of the enlargement, then the area, based on the enlargement, is just going to be 9.6 times 12, or 115.2 inches squared. If I'm using the original area would be 8 times 10, which is going to be 80. And then the new area is going to be equal to the scale factor of 1.44 times 80, which also gives me 115.2 inches squared. Doesn't matter which method I'm using, it's going to give me the same answer. Maggie must also produce a print whose area will be reduced by 25%. Determine the dimensions of the print to the nearest hundredth of an inch. Well, the area scale factor would be that 100%, and then reduced by means minus 25%, or would equal 75%, which as a number is 0.75. The linear factor would be the square root of that. Now, I'm not going to put in the decimal because I can use that exact value in my calculator. I can say that in this case, the dimensions were originally 8 inches by 10 inches. And I'm going to multiply both those by the square root of 0.75. Which means it's going to give me my new dimensions, which rounded to the nearest two decimal places are 6.93 inches by 8.66 inches.